Okay, today what we're looking at is the final build of the Jupiter robot 3D printed using the small N20 dual shaft motor, 30 RPM at 3 volt rated. However, if you've watched the videos on this from the first one where I started by repairing this original wind-up one, to doing the CAD work, to doing the legs, to designing the body, designing the head, you kind of know all that. I am also working on a version over here which will use the much larger TT type motor, including the blue TT motor. The blue ones have metal gears and they have some slower gear ratios, which would be better for walking. This particular one right here has got the 45 to 1, so it's a little bit fast, but it'll work. This supposedly is going to be 90, but you can see this is the single shaft version, so I had to order the dual shaft ones and they haven't come yet. But that's another project that we're not going to be working on today. What we're going to be working on today is this one. So let's focus in on that. Let me move some of the other stuff out of the way. Here we go. This is what we ended up with, using 2 AAA batteries, 1 flashing LED. We have the nice walking speed, moving arms, got the rotating antennas, and like I say, this was the first one, and I made a few changes since this design. Originally this one was using a boost regulator to change the 3 volts from the 2 AAA batteries up to 5 volts, because this gave a better run speed and power for the little N20 motor. And originally I was using a boost regulator that I had that was much larger and had a trim pot on it, and I could adjust it into any voltage. And I was waiting for these to arrive. Very inexpensive, less than $1. And it'll take anything from 0.9 of a volt up to 5 volts, but in this case we're getting 3 volts and boosted up to 5, and it can put out about 300 milliamps or so, but the little N20 motor is only drawing about 30 milliamps, so more than enough power to boost those little batteries up. And I'd been waiting for this so I could do the build video, because this is the type of little thing I wanted to use. And if you go back and watch some of the other videos, I'll actually show you where you can find these and how inexpensive they are. Okay, what else? I made a few changes on this one. The original one, you can see it's got this cap, and there was the legs on the Jupiter robot are purely cosmetic. Inside there are linkage parts that actually are the load-bearing part, but the leg is held in place by these slots in the bottom of the body and by a pin through the middle of the foot. But not only does that pin go through the middle of the foot and into the actual load-bearing part of the foot, it also holds the little ratchet piece that's on this front ratchet wheel in place. So it was very difficult to assemble the pin, the foot, and the ratchet, get it all lined up. I mean, I did it dozens of times, but it just wasn't an easy build. So I ended up changing that design, as you'll see when we build the one that we're going to be building in blue plastic, so you can tell the difference between the two, to make that much simpler to do. And I also changed the battery door. On this one, I went with this compression piece that you would bend down to bend that clip down, and then added a piece of pull. Can't think of the name of what I'm trying to say, but anyway, you pull on that to pop the batteries out, because they're inset, and it makes it easier to get the batteries out. But I changed the spring clip because on the next project, if we do go with the TT type gear motors, well, I know it'll be a way that we can do it, so we will be going with that. So I went with a slide latch on the door, because the TT motor is so much deeper, it's such a bigger motor, that the batteries are now pushed clear back, and this part that goes inside would hit the battery pack, and you wouldn't be able to use that design. I just wanted to use one design for the battery doors. So only this one has that type battery door. So let's see. I think we should start with the leg assembly that we were just talking about. Like I say, this whole outside piece is cosmetic. These two pieces here, these leg linkage, are the load bearing part. As you can see, they are connected to the actual foot. The rear one is free spinning. The front one is the one with the ratchet. Well, gotta hold it this way. You can actually almost maybe see the ratchet right there. So the wheel can only go forward and then it locks. Now there's a left and a right, not to the outer foot part, but to this leg linkage. The way that's inset, that's going to be facing in towards the guts of the robot, and the flat side will be facing out. This little protrusion up here is to enable the arm movement. So maybe we should start by doing one of those assemblies. Let me grab a few of the parts. Now I got the parts here somewhere. There they are. I couldn't see the wheels. The wheels, the ratchets. Now for the axle pins on holding all the parts together on this, with the exception of the one that holds the ratchet in place, I'm using these little wire nails, brad nails. We used to call them finishing nails when I was a kid, but they're sold in gauge. So this is an 18 gauge by 1 inch long. Well, an 18 gauge for those in the metric world would be 1.2 millimeters, as you can see there. And by getting that length, we can then cut them down to any length that we need if you've got a good pair of snips or dikes handy, so that you can cut them down, or a Dremel with a cutoff wheel on it. And like I say, the one axle that's for the ratchet, this is the ratchet part, and there's a left and a right to the ratchets. I'm actually using a paper clip for that because I need that really sloppy. I need that ratchet to fall really easily. If it hangs up, it's not going to ratchet. So it needs to move really easily. And I think we might actually start with that ratchet part first. I'm going to grab a few odds and ends here. This. Okay. Now you can get those little brad wire nails in all kinds of different materials. Here's some in a brass coated material. These are actually a little bit shorter, so I might as well use those up where I can, use the long ones where I have to. So let's start with the ratchet. This is a piece of a paper clip. And the idea is on this main foot part, you can see there's a nib there and there's a nib there. The nib on this side has got a hole so that you can in fact put, as you can see, a paper clip piece in there. Actually, I would actually prefer a piece of paper clip that wasn't so bent up and mangled. But this is what I got to work with at the moment. If it doesn't work, I'll grab another chunk. So I've cut it down so that it would fit inside like that. So I know it's the right length. And I've dropped it on the floor. And I don't know that my eyes are good enough to find it. Maybe. We'll give it a shot. I'm going to be using a little bit of E6000 to hold that paper clip in place. We're going to take the ratchet piece. As you can see, it's got a little square area that's going to be facing down. If you just kind of remember that part, you won't screw anything up. It's going to fit in there, so when this piece of the paper clip goes through, it's going to go through all of that. I'm going to put a little bit of that E6000 on the end of that paper clip before I shove it in all the way. Like that. It's actually quite a bit more than what I needed, but that's fine. And I just pushed it on in, and that holds the ratchet piece in place. And then it's a good time to make sure that the ratchet moves freely. Alright, so now that we know with that ratchet piece and that facing down the bottom, like I told you, this is going to be the front of that foot. You take one of the ratchet wheels. I've already snapped on a rubber grommet on there. So I buy my grommets and kits from like Harbor Freight, because you got all the sizes from the little ones up to the big ones, and the whole kit's less than 10 bucks. So I snap on the rubber grommet on there, and then we're going to take one of our wire nails, and then obviously, since the ratchet favors one side, the ratchet wheel is going to have to do the same thing. And again, I'm going to put a little bit of E6000 on the head of the wire nail, so when I push it in place, it'll hold it there. You can use whatever you want. Super glues might flow in and gum everything up. This is thick enough that it stays where you put it. So this is what we have now. As you can see, the ratchet works. The wheel can turn in one direction and it locks in the other. So now we got to put the rear wheel on, and you simply want to orient it to fit in the same direction as the front one. In other words, we want the rubber part, the O-ring, to be on the same side as we did in the front one. Like so. So here's our assembly so far. Got the ratchet one in the front, got the freewheeling turning one in the back, and now it's time to put on some leg linkages. Now, since we know this is the back, this plain looking linkage piece can go on the back. This particular one was an older file where I'd rounded 1/4, but I had forgot to round that. It doesn't matter which one goes in the foot and which one sticks up. It isn't going to make any difference. So again, we're going to grab one of our pins, and in this case, it's probably easier if I just put this on here and then show you the correct way that it's going to be aiming. Again, I'm going to put a little bit of the goop on the head of the nail. Just like that. So the flat side is going to face in on both of these, and the part that's pinned will face out, as you'll see. So this is the rear, the free spinning side. So that's our rear leg linkage. And here's our one for the front. And I just need another nail. It's fitting kind of tight. Kind of clearing that hole out here first. I think I'll go ahead and use one of the brass ones. I still have one of those sitting here. There we go. So I had some of those shorter brass ones, so I might as well use them up down here where they're a little bit too long, so you can see it's sticking out there. So we'll just go ahead and take the snips and snip the pointy end off. But so now you can see that the flat sides are facing towards the inside and the hoop parts are facing out. And the part with the long cam part, everything is the front, like so. So now we come down to the leg. Like I say, this is just cosmetic. You don't even have to put this on if you don't want to. But I print it this way on the printer with support material across the bottom and around this little part here. That's the only support material you need. Then you just clear that away. A little bit something up inside there. I don't want that in there. It might jam up against the wheel. So I'm going to clear that out. There we go. So we've got these two holes, and the idea is they're going to snap around the two nubs that are on this assembly. Now you kind of have to shoehorn them to get them in there, and I may or may not be able to do this part on camera. I may have to hold this in my lap to do it. But the part should allow you to spring it out far enough to start a nub on one side and then go over to the other side, and just like that it snapped in. So you got a nub in that hole and a nub in that hole, and now you have your foot assembly. Pretty cool, huh? Yes, pretty cool. Alright, so the next part, we're going to connect the legs to the base. Now on this base, to save a little time, I've already glued that power boost inverter that's going to change the 3 volts to 5 volts. And you have to glue it down low. If you glue it up here, when we go to put the body on, this part of the chest sticks inward and ends up hitting this. So this has got to be, it could be even down lower yet. But I know that that should be a safe place, so that should be fine there. And I've already screwed on the little piece of ribbon. The battery pack's going to be glued here, but we can't glue that on until after we put the legs in. You'll see in a second why. I'd already made this, so I just screwed it on there so I wouldn't lose it. But it's just a piece of ribbon where I doubled over the ends and super glued them to make them thicker, and then ran a screw. There's a hole provided. And again, it just, once you put the batteries in, if you leave that out, then you can just pull this and it'll pop the batteries out. Just makes it easier to get the batteries out so you're not fussing with that. Okay, so on the leg parts, we now know that the big hooped one is going to be the front. It's going to be near the ratchet. And we know that the inset part has to face inward. So we know that this leg has got to go on this side. Now we've got that little hole there, and we've got that hole there, and we want those to line up. And in this case, we're going to use the full length of those wire nails because they were like an inch long. And we're just going to pin them. I know the camera angle is not right for you guys to see what I'm doing here, but basically I ran that pin through the hole, through the part, and into a hole there, and it recesses in, so once we slide the body down, that nail won't be able to get out. You could put a drop of glue on if you were concerned about it getting free from you while we're doing this assembly. Now the back one here is a little trickier. I've pushed it up in the air so you can see it, but the idea is exactly the same. We're going to go through here, and then we want to pin that part. You can see how if we had that battery box glued in there, because it would cover this whole area. You wouldn't be able to see in there to drop the pin in. So those will want to kind of fall out until the body's on there. So like I say, a person could go ahead and put a drop of glue on there if they were worried about it too much. We do the other side. So the other one, we know this is going to be the front. Since that's inset, we know that's going to be there. So we know we built everything right. And we need a couple more of those nails. Looks like I'll have to open that pack and get one out. I guess I dropped a nail out the other side already. I guess, yep. Because of the amount of handling I'm going to have to do to shoot this video, I'm going to go ahead and put a little drop of glue on the heads of these nails. Let's see if that won't hold them in long enough for me to accomplish this. See, the back one here is already trying to fall out. And I got to do the front one because it did fall out with me moving everything around, trying to keep it in frame with the camera and get the job done. Not so easy. None of this is how you would actually be doing it if you weren't trying to hold it in front of the camera. You'd have it on your desktop. Okay. With a little bit of luck, just having something sticky on there might hold those. Okay, I need one more of those long nails, and they're inside here. There we go. And let's there we go. Let's get some glue on that. There. There, thank goodness. So, now we have both sets of legs pinned on and built. And so what we can do now is glue the battery box on. Like I say, it's just the 2AA. And it's going to glue onto that part right there. So I'll just put some, I suppose if you had hot melt glue, you could just use that. I'm not a big fan of hot melt glue, but it would be quicker. Gosh, darn it. Got it on my ribbon. Got it on my fingers. Got it everywhere but where I wanted it. No, I have it where I want it. So you can see them. It's a place for the wires to route up to the front. It's a place for the battery pack. You just want to make sure that it is flush, that it isn't sticking out, because if it sticks out further than that, when you go to slide the body on, you're going to have trouble. And you don't need trouble. So there isn't a whole lot more we can do to this piece until that battery pack dries, or we'll just be fighting it. If you wanted to do a few things to get ahead of the curve, hang on there a second. I'm grabbing some more parts. I'm grabbing the body actually, and the artwork. So another part that's going to end up gluing are the little pieces of the artwork. And the easiest way to do this is to make yourself a paper template that fits, and just keep trimming it till it fits in the front and the back ones. And then when you actually go to print out the artwork, scaling it on your computer using whatever program you have, it'll make it easier to know when you've got it scaled, and by laying that paper template on there, it'll make it easier to know how to trim the picture so that it'll fit in there. You could use spray glue, I guess, to hold this on. But since I'm already here, I already have the E6000 out, why not just use it? And there's one other change that I've made to the body that isn't shown on this one and this one, is I went ahead and hollowed those holes all the way out. The original windup had holes all the way through, and just to make it look closer. But these two bodies I'd printed before I'd made that change. Person could, if they wanted, go into those holes and put flashing LEDs even, if you wanted a light show down below. You just have to keep in mind where you're putting that voltage booster for the motor, so that there's room for it and the LEDs. And if you used red flashing LEDs, they could run off the 3-volt supply without going through the voltage booster, which is always good, because why boost it back up just to current limit it back down? It actually would just shorten your battery life. Okay, so we'll let all these parts dry, then we'll come back and we'll do a little bit more work on the Jupiter robot project with the N20 gear motor.